Hello student, in this video we will discuss about the derivation of formula to calculate resistance in series circuit. So for this I will tell you here that in a series circuit, total resistance is equal to the sum of the resistances of the resistors, sum of the resistances of the resistors connected in series circuit. Connected in series circuit. If in a circuit there are three resistors R1, R2, R3, etc. So total resistance on this matter, total resistance otherwise we can say total value of the resistance, total value of the resistance equal to resistance of first resistor, resistance of second resistor, resistance of third resistor up to R. How many resistors are connected? You will that means total resistance in a series circuit, total resistance in a series circuit is equal to the sum of the resistance of the resistors connected into series circuit. And now, so that is the formula. Now derivation of the formula, derivation of this formula. Now derivation of the formula. So now come at point. Before derivation of formula, there are some matters for your explanation that is must for you. You should know it in detail. I am taking here 3 points. Suppose one point is here, point P. One point is here, point P2. One point is here, point P3. And one point is here, point P4. Suppose in your circuit there are 4 points. And now we will care on the resistances connected on these points. So now potential difference is applied here in the conductor. So on this way, when current passes through conductor, so on point P1, there is ordinary conductor. There is only ordinary conductor. So its resistance will also be ordinary. But on point P2, there is another resistance connected here. So due to this, it happens that in circuit, value of resistance will change. So as the value of resistance will change, so the potential difference will also be changed here. Now potential difference V is here. In the case here, point P1, there is no any other resistance. So here potential difference will be normal as it here. The potential difference is here. In the same value, potential difference will also be here. So suppose that is the B. But on point P2, there is high value of resistance, another value of resistance than this here. Value of resistance varies from the resistance from here. In the circuit, the resistance that is here, this resistance is varied from this resistance. So here resistance is varied. So on point P2, potential difference also will change. So suppose there is potential difference V1. Now, if we talk on point P3, so there is also no resistance, means value of resistance is changed. So on this point, value of potential difference will also be changed. Suppose there is V3, there is V2, and after that, if we see in the case of resistance R3, so you will see that here resistance is varied. So after that, the potential difference on point P4 will also be changed, varied. Suppose it is V3. So in this way, one again what I am telling, ABC, that because this potential difference is applied into circuit, so this in this conductor on point P1 there is only ordinary conductor. So potential difference will also be ordinary V only. Here is V, so here will also be V. But on point P2, resistance is changed. Value of resistance is changed than this point. So their potential difference will also be changed. If we see point P3, so there is also change resistance. So potential difference will also change. On point P4, resistance is changed. So potential difference will also be changed. So means on this matter I will tell you here that in series circuit, potential difference is variable. Potential difference is variable because in series circuit resistance is variable. There are different type of resistance, different value of resistance is connected into circuit. So potential value of potential difference will also be changed. First, second. But in the case of current, I will tell you here, the current is going straight. Current is going straight. Now I am telling you case. Suppose the current is going here, but if current is changed, current is distributed. If current is distributed, current is going here. Suppose some current goes here, some current goes here, some current goes here. So in this case, current is distributing, but here there is no distribution of current. Current is going straightly, here to here, here to here, here to here, here to here. So it happens this on this basis. I will tell you here. In series circuit, value of current is always constant, but value of potential difference is variable. Value of current is always constant, but value of potential difference is variable. And this variable, total value of these variable potential differences is equal to the potential difference of constant that is applied into circuit. Means we can say that potential difference, constant potential difference is equal to V1 plus V2 plus V3. Suppose equation 1. At constant current. At constant current. Why at constant current? Because I told you that in circuit, in series circuit, current is going constant. Current is going straightly. Here not a distribution of current takes place. So current is constant. But potential difference is variable. So total value of variable potential difference is equal to the constant potential difference that is applied into the circuit. So on this way, I will tell you here. So at constant current, total value of variable potential differences, is equal to the constant potential difference applied into circuit. Constant potential difference applied into circuit. So suppose here are three resistors R1, R2 or R3. There are three resistances. So for these three resistances, value of potential difference will also be varied as a 3. For R1, V1, R2, V2, R3, V3. Means for resistance R1, value of potential difference will be V1. For the value of resistance R2, value of potential difference will be V2. And for the potential difference of R3, value of potential difference will be V3. So on this pattern, according to this statement, V equal to V1 plus V2 plus V3. Suppose equation 1. Now, clear? So on this matter, I will tell you that here that now according Ohm's law, Ohm's law. Now according Ohm's law. Now according Ohm's law, it happens that V equal to I into R. Suppose equation 2. So V equal to I into R equation 2. So V1 equal to I into R1 equation 3. V2 equal to I into R2 equation 4. And V3 equal to I into R3 equation 5. Why? When current is constant. When current is constant. Now, when current is constant. So now, placing the value of equation 2, 3, 4 and 5 in equation 1 again. By placing the value of equation 2, 3, 4 and 5 in equation 1. So, now command point, what can we write? For the value of V, we will write I into R. For value of V1, I will write I into R1. For V2, I into R2. For V3, I into R3. So, see this, but placing the value of equation 2, 3, 4 and 5 in equation 1. Equation 2, 3, 4 and 5 in equation 1. So what happens? I into R equal to I into R1 plus I into R2 plus I into R3. Suppose equation 6. Now what happens? So we can write here taking as common or taking common. What happens? I into R equal to I into R equal to I R1 plus R2 plus R3. Now I to I cancel. So R equal to R1 plus R2 plus R3. That's all. That is the value of total resistance of the resistors connected into series circuit. Means total value of resistance in a series circuit is equal to the sum of the resistors of the resistances connected into series circuit. That's after that. For its implementation, very easy. See how it happens. Suppose there are three resistors. 1, 2, 3. There is here connecting on potential difference B. Due to this, I current is passed. R1, R2 and R3. Suppose if the value of resistance R1 is 2 ohm, value of resistance R is 3 ohm, and this is the 5 ohm. So calculate the total value of the resistance in the circuit. So what happens now? Total value of resistance R total equal to R1 plus R2 plus R3. So R total here is equal to R1 2 ohm plus 3 ohm plus 5 ohm, means you can say 10. That's all. So total value of resistance is 10 ohm. That's all. Sometimes it happens that now in other way it is said that due to applying these resistances, if the current of 5 ampere is passing here, if value of current is 5 ampere, suppose due to these resistances, current of 5 ampere is passing through circuit, so calculate potential difference. So here given resistance equal to 10 ohm, current I equal to 5 ampere. So now calculate potential difference. So according Ohm's law, solve. According Ohm's law, it happens that V equal to I into R. Potential difference is I into R. Now, value of potential difference is not given here. So, value of potential difference is equal to I, 5 into resistance 10. So, potential difference equal to 5 times 50 volt. That's by this way numericals will be asked to you. In next video I will solve this type of numericals. That's all, and I'll put this in next video.